जब भी हम किसी रोड पर ड्राइव करते हैं और पानी नीचे से चला जाता है विदाउट डैमेजिंग द स्ट्रक्चर, तो उसके पीछे छुपा होता है एक स्ट्रक्चर। क्या आपको पता है उसे क्या कहते हैं? वी कॉल्ड इट एज अ कलवर्ट। स्ट्रक्चर छोटा होता है लेकिन इम्पोर्टेंस बहुत बड़ी। आज की इस वीडियो में हम देखेंगे कलवर्ट क्या होता है, इसका पर्पस क्या है, कितने टाइप्स के होते हैं और रोड और रेलवे प्रोजेक्ट्स में इसका रोल क्या है, इम्पोर्टेंस क्या है। So let's start. What is a culvert? A culvert is a tunnel built under the road or train track to help water flow in both directions or to move electrical or other lines from one side to the other. The primary function of a culvert is to redirect water flow from one side of the obstruction to the other, ensuring the continuous movement of a water and minimizing any negative impact on transportation or the surrounding environment. By allowing water to pass underneath, culvert helps to maintain the integrity of a road, railways and other infrastructures. Now the next materials used to construct a culvert. Depending on the expected water flow, environmental conditions and budget, culverts can be made from the various materials like concrete, steel, aluminium, masonry, high density polyethylene and polyvinyl chloride. So we'll take one by one in detail. So the first one, concrete culverts. Concrete culverts are widely used for durability and strength. Reinforced concrete pipes or the precast concrete sections are commonly used to construct culverts. Steel culverts are often used when high strength to width ratio is required or must be fabricated and transported to the construction site. Corrugated steel pipes are commonly used and are available in the different shapes and sizes. The next material is aluminium. Aluminium culverts are the lightweight and the corrosion resistant, making them suitable for culvert installations where wet or corrosive conditions exist. They are commonly used in the coastal areas or the locations with high salt content in the soil. Then next material is a masonry. In some cases, masonry materials such as bricks or the stones may be used to construct culverts, and these materials are often used for smaller culverts or when the aesthetic considerations are the important. Then the next is high density polyethylene, HDPE. HDPE culverts are the lightweight, flexible and the corrosion resistant. They are typically supplied as a large diameter corrugated pipes or culvert sections, and HDPE culverts are the easy to install and they require minimal maintenance. Then next type of a culvert is a polyvinyl chloride, PVC. PVC culverts are the lightweight, durable and the corrosion resistant. They are commonly used for smaller culvert applications such as residential driveways or agricultural drainage systems. PVC pipes are available in various diameter and can be easily connected using fittings. The next point is design of culvert. The design of culvert considers several factors to ensure its functionality, structural integrity and the efficiency in the managing water flow. So there are the many points like hydrological analysis, hydraulic considerations, then structural design, inlet and the outlet design, the next site conditions and construction and the maintenance consideration. So considering all these points we can design culverts. So we'll take all these points in detail one by one. The first one is hydrological analysis. The design process begins with an assessment of the hydrological characteristics of the area, including the anticipated flow rates and the volume of water. Then the next point is hydraulic considerations. Based on the design flow, the hydraulic properties of the culverts are determined. Like it involves the calculating the size and the shape of the culvert to accommodate the expected water flow without causing excessive backwater or the flooding. Hydraulic considerations also involves determining the entrance and the exit conditions of the culvert to minimize energy losses and promote efficient flow. The next point is a structural design. The structural design of culverts involves selecting the appropriate materials, shapes and the dimensions to withstand the loads and the forces it will experience. Factors such as the type of a traffic above the culvert, soil conditions, and the anticipated water pressures are also considered in the designing culvert. Then the next point in the design of a culvert is inlet and outlet design. Proper design of a culvert's inlet and outlet is crucial to maintain efficient flow and prevent erosion. The inlet should be designed to control the flow's entry into the culvert, minimizing turbulence and the potential blockages. Similarly, the outlet must be designed to avoid excessive scoring and erosion downstream. Now, the next point we'll consider in the designing of a culvert is nothing but the site conditions. The physical characteristics of a site, such as the soil conditions, groundwater levels, and the slope stabilities, plays a significant role in the design of a culvert. And the next point we consider in the designing of a culvert is construction and the maintenance considerations. The culvert design should consider construction feasibility and the long-term maintenance. Factors such as the ease of installations, accessibility for the maintenance and the inspection, and the durability of the materials are considered to ensure the culvert's durability and the cost effectiveness. Now the next point is different types of a culverts. The first one is a box culvert. A box culvert is a rectangular or the square shaped structure and commonly constructed using reinforced concrete or precast concrete segments. The structure consists of a multiple interconnected rectangular or square boxes forming a continuous conduit. The boxes are usually designed to withstand the external loads exerted by the soil and the traffic passing over them. Box culverts safely and efficiently transport water, especially during the severe rainfall or floods, allowing the vehicles or the people above. The next type of a culvert is arch culvert. Arch culverts are made of concrete, stone, brick, or metal. The predicted water flow, stream of a drainage channel size, and the traffic or railway requirements determine an arch culvert size and the dimensions. Arch culverts can support higher water flows or broader highways. The design considers hydraulic capacity, sediment movement, and the environmental issues to prevent flooding and damage. Next type of a culvert is a pipe culvert. It is made up of a concrete, steel, or the plastic pipes or the set of pipes. A pipe culvert allows water or other fluid to flow from one side of the road or the railways to the other. The projects determine the pipe culvert size. The most prevalent shapes are the circular, elliptical, and the rectangular. Due to their structural economy and the hydraulic performance, round pipes are the commonly employed. Then the next is a bridge culvert. A bridge culvert combines the function of a bridge and the culvert. It allows the water to travel under a roadways or railways while providing a bridge for the vehicles or the pedestrians to cross the watercourse. Bridge culverts have a highway or the railway deck supported by abutments or the pier spanning the canal. The deck is usually made up of a reinforced concrete or steel girders for strength and the load bearing. Now the next is metal box culvert. The metal box culvert is designed to provide a strong and the durable channel for water flow, allowing it to pass under a roadways or other obstacles. It is commonly used when the open channels or bridges are not feasible or the appropriate. The culvert is usually constructed in sections or connected segments to form a continuous conduit. These segments are typically prefabricated offsite and then transported to the construction site for installation. Next is advantages of culverts. Culverts minimize flooding, erosion, and the waterlogging by efficiently directing water. The next is roads, railways, and footpaths can be smoothly linked with culverts. This integration minimizes the construction disruptions and maintains transportation networks. Then the next point is bridges cost more than the culverts because culverts requires the less foundation works, foundation materials, and the building time. The next is culverts can be designed and built in the various sizes and the materials, and because of this adaptability we can offer customized solution based on the predicted water flow, site circumstances, and the load bearing capacity. Culverts are easier to maintain than the bridges, and culverts can also provide inspection and the maintenance access points. The next is disadvantages of culvert. During the high rainfall or floods, culverts may overflow. It can cause the upstream flooding. The next, debris, sediment and the vegetation can clog the culverts, and water blockages causes localized flooding and the infrastructural damage. Then the next point is maintaining culverts is essential. Preventing blockages and the deterioration requires clearing waste, sediment and the vegetation and the restoring the damages. Erosion and the soil near the culverts can result from the poor design and the installation. Culverts can only carry a small amount of water or traffic. So these are the different disadvantages of culverts. So in this video we cover all the details about the culverts. Hope you found the content of the video useful. If you like it, please share with your civil engineering friends and subscribe the channel.